Good time of day, dear colleagues. Thank you for the participation, the opportunity to participate in a conference that is so representative. Today I'd like to talk about the difficulties that we face when we try to automate the design of new technical solutions, and also the opportunities that AI provides us to solve this problem. At the moment, there are lots of tested ways to generate new technical solutions. Those are morphological analysis, the innovational modeling, and different sorts of synthesis, described in the works by many prominent writers. And I will be specifically talking about the ways that we have applied in our university. I'd like to talk also that there are many automated systems that help to invent the systems that generate innovative solutions, but here, in this particular sense, it's important to note that we're not talking about how to help human beings invent. It's about what these systems are lacking. Where can we get the data for these methods? How is it possible to accumulate the most advanced knowledge in physics, chemistry, biology? Where is it possible to find the data, and how the data can be extracted with the tools of AI? On the next slide, there are answers to these questions. There are over 50 million patents now registered in the world. We've been using current databases of Russian and American patent agencies. These are the open sources. Overall, we have processed over 300,000 Russian and over 3 million American patents that were granted in the last decade. On this slide, you can see the list of patent information. This is the patent application form for Russian and for American United States patent agencies. This structure of information is slightly different, but both application forms have valuable information, which is the name, the number, the note, the annotation, and we're mainly interested in the text description of the invention and the production unit, which are again described as a text. Computer linguistics, as one of the branches of AI, allows to make machine-based approach. It can also sense the tone of the text, but for this particular task we would need the technology of computer linguistics that's called semantic analysis of text. And subject-action-object structure is a key concept that helps us to identify in the natural text the information that we need, such as the one described in patent, the technical object, the functions, the components of the object, technical problems, needs, and how they can be solved. On this slide, we can see the example of text analysis, specifically in order to extract technical functions of a particular object. On the left, there is an example of how the dependency tree is built with the theory, subject, action, object, and I should say that the analysis of text and patent applications showed that they need to be adapted for the AI analysis. So we did that adaptation, and now in the table we take into account the actions that are made by the object. And conditions for those objects to be executed. It's based on the paradigm of distributed computations MapReduce, the frameworks with open source code for distributed computation, Apache Spark from the Hadoop ecosystem, we've been using HDFS file system, which has high data throughput and also allows parallel processing. We've also applied ML libraries. And we've also used the RDD toolkit for collecting of distributed data. We did the computation using cluster of the Volgograd State University. Let us talk about specific approaches to generate new technical solutions, i.e. inventions. Here's the approach based on morphological analysis. We used it to explain what we actually did there. The fundamental concept of morphological analysis is the search for technical solutions of maximum effectiveness, meaning that there is extrapolation of technical system that includes the number of objects. We're also searching the alternatives as a particular technical implementations of those objects presented by the executed technical functions, combined solutions based on alternatives, and selection of the best alternatives. On this slide on the left, it is possible to see this graph over the technical objects on top and technical functions below. So, question is, where do we get this information? It's important to create a database that contains data about technical components of the invention. Also, it is important to have the data about the actual technical implementation of the objects and devices, based on the functions that they are claimed to be able to execute. Obviously, all of this information can be in the description of the invention in the patent. So on the slide we can see how, based on the text of that describes the function of the device that was patented, this is the patent for ball bearings particularly. So we have extracted particular components and ties. Therefore, they will become the parts of morphological matrix. In addition to this information, we put alternative data sets into the morphological matrix, and alternatives of these technical objects, including all of the technical implementations of the ball bearings that are available in the data set of patents. Also, in this morphological matrix, we highlight the key differentiating function of this technical implementation. All of these processes for analysis of text data extraction were automated with the use of computer linguistics methodology for both Russian and English language. Of course, every device can be part of another device. For example, ball bearing can be the part of a more complex machine. So these ties, these connections are also preserved. And therefore, the selected morphological matrix is a combination of all available options in the patent data set. On this slide, it is possible to see how you can see the process of extraction of descriptions of certain devices from the text of patents, and this extraction is based on the very same semantic structure, SOW semantic structure. But this semantic structure can also aid in the extraction of not only this information, but also in the extraction of the set of problems solved by a particular device or devices that were patented. And this sort of data put into one data set can actually help in various researchers. Or, for example, just to help find the R&D partners. As I've said, thanks to morphological synthesis, it is possible to combine different functions for the elements of the technical system. Therefore, it is possible to get the endless number of results. Therefore, we're approaching an issue of how we can get the evaluating morphological signs and features. Technical functions are extracted from patent documents based on text analytics. Then we get this matrix of extracted information. Then we do clusterization. This is a matrix to highlight the major technologies in the inventions. After that, this patent dataset that was clustered is analyzed according to timestamps, and after that it's possible to highlight certain patent trends. As well, it is possible to put together the set of key functions that correspond to modern technologies, and the evaluation of technical functions in our case is a part of both its presence in today's major inventions and technologies, and also from the forecast of how often we can see it in the future. Another thing that we can say here is that this particular technologies can be distributed not only onto technological functions, but also on tech objects and problems that can be solved by particular devices. As a result, they have developed the oncological database that contains data about elements of technological systems, about implementations of tech objects that can be solved with technical systems and technical functions. Another method to generate new technical solutions. This is the concept of a new system that's based on the level of physical operations, with the use of the physical effect. That is describing the interconnections between the certain physical phenomenon, the object of that phenomenon, and the output result of that effect. On this slide, you can see the example of physical effect. For example, using heating to demagnetize. So there is 1,200 descriptions like that, and it's possible to generate new technical approach based on the available descriptions. So the synthesis of the physical principle here generates the linear structure of the physical effects that are connected to one another. But we should highlight here that the physical effect data set, the core of it, was made in the 80s and 90s. So it's been put together manually. There could be years passing from the moment of the discovery in physics till the moment when the information was analyzed and the particular physical effect would get into the database. It's clear that in modern realities we don't have time to fire up. The new materials and discoveries should go right away into the generation of new technological devices. So we are using the methods of computer linguistics as the methods of AI to look for articles in physics and to find new physical effects in the patent applications. Here are the methods based on natural language processing. We're using these methods. We analyze text based on semantic structures, subject, action, object. We're also using statistical analysis of the text, for example, context, synonyms that were extracted through training of the massive, based on the massive of physical texts. As a result, we can get the elements of physical effects, and that helped us to put together the descriptions of 210 new physical effects in addition to 1,200 existing. It's also worth noting that a physical effect is not a certain material, and it's not actual physical phenomenon. This is a phenomenon that's described on the level of rules and laws of physics, such as the law of Ohm, for example, Ohm's law. So we have been able to broaden the knowledge base of physical effects and the approaches that we have tried and tested. And the sphere could be applied to put together the database for example, biochemical effects, not only physical effects. On this slide, there are the results of tests and trials of our approaches. Actually, we have been able to get patents for a few devices that describe technical systems based on this ordered database of physical effects. In addition, the approaches and analysis technologies, the description of the newest and most advanced discoveries that we have developed, allow us to claim that we have truly made a step towards automation of generation of the new breakthrough inventions. Briefly, this is the way I wanted to describe how computer linguistics can be applied to actually analyze patent applications and then generate new discoveries, so that the humanity would approach closer to this dream that's existed for centuries, the dream of some inventful machine that without any particular training, without any particular knowledge requirements, would be able to make new inventions on a daily basis. The analysis of the large data set of patent applications, lots of text, is a way to solve the problem. In addition, I would like to thank my mentors, Mr. Kamaev, Mr. Fomenkov, and Ms. Karavets, for pivoting me towards this problem. Thank you so much for your attention.